Okay, I will be giving you your exams back on Wednesday. I have sent you an email right before I came here, and the email has an Excel file attachment. And remember I talked about the big diet problem I gave you a small diet problem in the exam, but there is the bigger version of that is what I sent you. I only sent you the Excel file, so you have to solve the diet problem and see what your diet should be, the cheapest diet you can come up with. That's going to give you all the nutrients that you need. Okay? Yeah, it is. I said that next week on Friday. That's just like. Oh, I forgot to bring those cards with me. I still have those cards. I'll just bring them on Wednesday and let you know. So, I mean, it should be easy now once you have done that exam problem. It's just a bigger version of that. Okay, so let me start from where we ended last time. So I gave you a sort of a big picture of the Simplex method, and I said that the Simplex method consists of dictionaries, and you move from one dictionary to the next by using an operation that we call pivoting. And we have you can divide the Simplex method into two steps. One is initialization. The other step is the optimization. The operations involved in both of them are the same. However, initialization means that your initial dictionary is infeasible, and then you want to apply your operations to come up with a feasible dictionary. So initialization here, these are so on this side you have infeasible dictionaries. Okay, so let me write that down. On the initialization side, the dictionaries are infeasible. Infeasible. Is somebody there? And you apply your pivoting operations, and you come up at some point. You come up with your first feasible dictionary, and after that, all the dictionaries are feasible. Okay, so in the optimization step, all the dictionaries are feasible. And for the moment, we are going to concentrate on the optimization step, and then we are going to speak about the initialization step later. Okay, for now, we are always going to assume that we start with, we are too lucky, we are very lucky that our initial dictionary will be a feasible one. So we don't have to worry about initialization. That's the last thing we did, right? I think so. So this is the last thing we did. And okay, so now let's think about the optimization step, and I want to go over a complete problem today on the optimization step, and I'm going to show you what we mean by pivoting. And I think I gave you the description of the pivoting last time. Is that right? Okay. So where am I? Okay. All right. So let's go back to the example that we had. Here's the example. We want to maximize the objective function, which is given by 3x1 plus 5x2, and subject to subject to certain constraints, which are x1 plus 0 x2 less than or equal to 4, 0 x1 plus 2 x2 less than or equal to 12, 3 x1 plus 2 x2 less than or equal to 18, x1 is larger than 0, x2 is larger than 0. And what was our first step? You guys remember the first step? The first step is that I have to write down the slack form, right? S-L-A-C-K, slack form. And what is that? The objective is the same, right? In the slack form, the objective is still the same, 3x1 plus 5x2. And then what are my constraints in the objective? Well, for each inequality, I introduce a slack variable. Since we are using x1 and x2 already, we're going to use x3 and x4 and x5 for the slack variables. Each slack variable has to be a new one. Okay, so I get x1 plus 0 x2 plus x3, that's the slack variable, is equal to 4. So what is the meaning of x3 then? x3 is basically 4 minus the left hand side of the inequality, right? The other one would be 0, the second one would be 0x1 plus 2x2 plus x4 equals to 12. The last one would be 3x1 plus 2x2 plus x5 equals to 18. Okay? And I want x1 larger, x1 is larger than 0, x2 is still larger than 0, and I want x3 to be larger than 0, x4 to be larger than 0, x5 to be larger than 0. Why do I want them, the slack variables, to be larger than 0? Well, if I allow the slack variables to be negative, so for example, if I allow x3 to be negative, that would mean that I am allowing what here? Well, that would mean this inequality will not hold anymore, right? Because what is x3? x3 is basically 4 minus that, right? In order to preserve that, I am letting x3 to be, which one is bigger, 4 or the left hand side? The left hand side is the smaller side, and we are letting x3 to denote the difference, 4 minus that. So we need these variables to be non-negative. Alright, so this is the slack form. And once we have the slack form, then we write down our initial dictionary. Now, what is a dictionary again? Once I have the slack form, then I have to designate some of the variables to be basic variables, and I have to designate the remaining variables to be non-basic. What are the other terms? Independent or co-basic, right? So again, once I have the slack form, designate some of the variables to be basic, and the remaining of them will be called non-basic, co-basic, or independent, whichever you like. Now, how many basic variables should I designate? How many basic variables should I designate? Anybody? How many of the variables should I designate as basic variables? Was that 3? 3 is correct. Why? Number of functional constraints, right? Number of functional constraints is the same as the number of basic variables. So you have a choice. You have a choice to designate your basic variables. But what we are going to do is that we are going for our initial dictionary, we are going to take we are going to designate the select variables to be the basic variables. Okay, so let's do that. So our first initial dictionary, so initial dictionary, and what will that be? I hope you have written them down, so let me just write here. We are going to write x3. So you're basically going to solve each equality from the select form for the select variables. So I get x3 is 4 minus x1 plus 0 x2. I'm going to solve for x4. That will be 12 plus 0 x1 minus 2x2. What would be x5? 18 minus 3x1 minus 2x2. Could you guys not use the keyboard, please? That noise is going to interfere with others. x5 is 18 minus 3x1 minus 2x2. And what is z? Z is 0 plus 3x1 plus 5x2. And I'm going to use a separation here to separate the objective function. Now, what are our basic variables? The basic variables are on the left hand side. So these are the basic variables, and the variables that appear on the right hand side, they are the non-basic or co-basic variables. Now each dictionary has an associated solution. What is the solution associated with this dictionary? How do we find the associated solution? What's the associated solution? What do? We set non-basic to 0, solve for basic. So if I do that, x1 would be 0, x2 would be 0, or maybe I should, let me clearly write them down as x1 would be 0, x2 would be 0, x3. Once you set them 0, notice that the first column, the numbers in my first column on the right hand side, they give me the values of the basic variables, right? So what is x3? 4. What is x4? 12. What is x5? 18. I don't have to do anything. I can just read off the values, right? Now, is this a feasible solution? Is this a feasible solution? How do I detect if it is a feasible solution? Well, because all the values of all the variables are non-negative. And once I know they are non-negative, they are going to preserve all the constraints. Why? Because I set some variables to 0 and I solved for the others, so I didn't violate any of the equalities here, right? You realize that? We did not violate any of the equalities because we set the variables on the right to be 0 and solved for the others. So the equality is preserved while all the components are non-negative, which satisfies the non-negativity constraints. So this is a feasible solution. When one of the numbers in the first column is negative, then we get a infeasible solution. You see that? Okay, now how do I write down the next? So go to the next dictionary? Well, I have to use an operation. We called that operation the pivoting operation, right? So first of all, I have to make a choice. I have to make a choice for an entering variable. So what would be the entering variable here? Entering variable. Well, how do I choose an entering variable? I look at the row for the objective function and see if there are any variables with non-negative coefficient. I should say positive coefficient. Is there a variable in the row for the objective function with positive coefficient? The answer is yes, there are two. x1 and x2, they both have positive coefficients. Why does that mean that x1 and x2, any one of them could be an entering variable? Because I can increase the value of the objective function z by increasing x1 or x2. Well, you should compare that with the situation where I have the coefficient of x1 is -3. In that case, if I increase x1, I am actually decreasing z. So that's not a good thing to do because I'm trying to maximize z. Am I making sense? So how am I going to choose my entering variable? Look at the row for the objective function and identify the variables with positive coefficients and pick one of them to be your entering variable. So what I'm going to do here is that I'm going to make the following choice. I am going to choose x1. Usually if I am actually doing this problem, I'll probably choose x2 just because z increases faster in the direction of x2 than x1. However, I'm just going to make this choice just to show you that this is also a valid choice and to sort of see how the simplex takes different paths depending on what you're choosing here. Okay? And we are going to talk about how we should choose more efficiently and so on later. Those details will be left for later. Right now, I just want to go over one complete solution. So choose x1 as the entering variable. Then, what do? I have to choose entering. What is the meaning of entering? With respect to what? When I say entering what? Entering the basis, right? So, what is the basis? Basis is the collection of basic variables. Now, going from one dictionary to another simply means that the basis is going to change. How? One of the non-basic will go into basic, one of the basic will go into non-basic side. Okay? So your basis is going to change. So now I have to choose a basic variable to become non-basic. That means I have to kick out one of the basic from the basis. So that means I'm choosing a leaving variable now. I am choosing a leaving variable now. So what criteria do I have to follow to choose a leaving variable? Does anyone remember? So I am choosing what? I am choosing x1 to be in the basis, right? In the next dictionary. But x2 will still be non-basic. So that means I am keeping x2 0. I am not changing x2. I'm keeping x2 0. I am only increasing x1. So because of that, I can ignore the column for x2. So now just focus on the column for the constants 4, 6, 4, 12, and 18, and the column for x1. And you ask yourself, how much can I increase x1? How much can I increase x1 by preserving all the equalities? Okay? Am I making sense? So how large x1 can I pick? That's the question that I'm asking. How do I come up with that? If you try to answer that question, how large can I pick x1 without violating any of the constraints? That answer is the same as asking, as I increase x1, which of the basic variables is the first to become 0? Which of the basic variables is the first to become 0? Well, let's look at the first equation. It says x3 is 4 minus x1. Remember, we are keeping x2 0, so I don't care about the last column. What do we need? We need this guy to be non-negative. What would that mean? Anybody? What does it mean to say that x3, 4 minus x1 has to be non-negative? It means x1 has to be less than 4, right? You guys can solve that inequality. Okay, now x4 is 12 plus 0x2, right? And I want that to be non-negative. What does it imply about x1? Sorry, did I say x2? I should be saying x1 there, right? Sorry. So this would be 0x1, sorry. What can I say about x1 here? Could be anything because the coefficient is 0. It doesn't matter how big, small I pick x1, the value of x4 is always 12, right? So x1 could be anything. So x1 could be anything. So it doesn't say, it doesn't give me any bound for x1. I could pick x1 to be anything. What about the last one? x5. In other words, it says that x4, no matter what you pick, how big x1 you pick, x4 will never become 0. Right? What is x5? 18 minus 3x1. And I want that to be negative, non-negative. And what does it tell me about x1? Less than or equal to? Everybody realizes that? Okay, I'm not showing you any details about this inequalities. I'm pretty sure you can solve inequalities by now. And then, so what does it mean? It means that as I increase x1, right? As soon as x1 reaches 4, x3 becomes 0. Right? As soon as x1 becomes 4, x3 becomes 0. x5 becomes 0 when x1 is 6. Right? So which one goes to 0 first? x3 is the one which goes to 0 first, right? So what? And notice that in order to answer that question, I basically said how large can I pick x1 without violating any of the constraints. Can I pick x1 any bigger than 4? No, because if I pick x1 bigger than 4, I am violating this positivity constraint here, right? So this one is bigger than this one, so I have to pick the smallest one here. So my point is x3 is the first variable, basic variable to go to 0. So let's highlight that. That's my leaving variable then. So my leaving variable x3. I don't have a choice here. Now let me ask you this. Suppose that when we are doing this analysis, I see that two variables go to 0 at the same time. So let's say x3 and x5, they both become 0 when x1 is 4. Then, which one should I pick as the leaving variable? Doesn't matter. Pick any one of them. Am I making sense? Suppose you have two candidates for the leaving variable. Pick one of them. Again, that would mean that as x1 reaches 4, both x3 and x5, let's say, becomes 0. Okay, when x1 reaches 4, let's say both x3 and x5 become 0. In that case, I can pick any one of them to be the leaving. That's not the case here. We have just one choice here. Alright, so x3 is the leaving variable. Fine. How do I write down the next dictionary now? Well, the idea is you are going to exchange the entering and the leaving. How? Well, go to the equation where both the leaving and the you realize that each basic variable appears only once in the equations, right? each basic variable appears only once in the equations, right? x3 doesn't appear in more than one equations, right? So go to the equation for the leaving variable, and then from that equation solve for the entering variable in terms of the leaving variable. So what am I going to get? Am I making sense? Go to the equation for the leaving variable x3, solve for the entering variable x1, and then whatever value of x1 you get, plug that in x4 and x5. And then you're going to get a new dictionary where the right hand side will be in terms of x3 and x2. The left hand side will be x2, x4, x5. Is everybody clear on what I said? So let's do that. I guess I have to go down here. So x1 was the entering, right? Am I correct? So I get x1. What is x1 equal to? Anyone? x1 equal to what? 4. When you solve for x1, what do you get? 4 minus x3 plus 0x2, right? What do I get for x4? What would I get for x4? I'll get 12 plus 0x3 minus 2x2. You agree with that? Remember, we are replacing x1. So what is that? So right now, once I solve for x1 in terms of the leaving variable x3, this is what I get, right? And then what I'm going to do is I'm going to put that in place of x1 right here. I'm going to put that in place of x1. But the coefficient of x1 is 0, so that's why you're not really getting anything for that equation. Am I making sense? But I'm writing 0x3 because to show that x3 is taking the place of x1. Am I making sense? Maybe let me write this. So can someone tell me what is the second equation that we had? The second equation was x4 equals to what? 12 plus 0x1 minus 2x2, right? Is that right? That's the second equation. So what I'm saying is that you are going to replace x1 with 4 minus x3 plus 0x2. Am I making sense? Minus 2x2. You're going to replace x3 by that. Is it clear? Not x3, sorry. You're going to replace x1 by that. So what I did is I replaced this x1 by the value of x1 here. When I do that, I'm going to simplify that in terms of x3 and x2. These are the non-basic. x3 and x2 are the non-basic. I'm going to write it in terms of x3 and x2. If I do that, I'm going to get 0x3 minus 2x2 again because the coefficient is 0. Is it clear? Okay, what would be the equation for x5? Do you guys need me to go over the details here? Okay, what is x5? What would be x5? Let me erase this and sort of show you the x5. Maybe once for and all, let me show you one detail here. So what is x5? x5 was 18 minus 3x1 minus 2x2, right? So what am I going to do? I am going to put in the value of x1 right here, right? There. So what do I get? 18 minus 3 times 4 minus x3 plus 0x2. I'm not going to write it. Minus 2x2. And if I plug in x1, and then I'm going to write the entire thing in terms of x3 and x2. So what do I get? 18 minus 12, right? What is that? What am I getting for x5 then? Yeah, 6. And then am I getting plus 3x3? You agree? And minus 2x2, of course. Is everybody okay? Okay, so if you're okay with that, let me erase this work. Again, the idea is, first of all, go to the equation for the leaving variable, solve for the entering variable in terms of the leaving variable, plug that in every single equation, rewrite everything, all the equations, and you're going to get your new table. I haven't done one more. I have to do one more thing. I have to change the row for the objective function. Remember the object. So what would be the objective function now? What was z before? Z was what? 0 plus 3x1 plus 5x2. And then what should I do? Replace x1 by 4 minus x3 plus 0x2, but that's 0, and plus 5x2. So if I do that, what am I getting for z? Anyone? 12 minus 3x3 plus 5x2. And let me erase that again. So this is called the pivoting operation. Once you choose entering and leaving, this operation that we did in order to rewrite the dictionary in terms of the new basic variables and new non-basic variables. And again, I'm going to use a separation here to separate the objective. You don't have to, but I will. Okay, so that's our new dictionary. Are we okay with that? Now, let me ask you this. What would be my next? Have I achieved my optimal solution yet? How do I know I haven't? How do I know I haven't? Anyone? How do I know I haven't obtained the optimal solution? In the 0, I still have a positive coefficient for x2. It means that I can still increase z in the direction of x2. That doesn't mean I can, but there is a possibility. So we have to check. So we're going to choose now what would be the entering, my new entering. If you don't mind, let me use ENT, VAR to denote that. That would be x2. And what would be my leaving? What is my leaving variable then? Now I can forget about the column for x3, right? Because in the next dictionary, x3 will be still non-basic, which means that we are keeping x3 0. So forget about the column for x3. Look at the other two columns here. Now the first equation then becomes what? The first equation says I have x1 is equal to 4 minus x3, not x3, sorry. 4 plus 0 x2, and I want that to be non-negative. Does it put a bound on x2? No, because I can pick x2 to be as big as I want, and still x1 is 4, and which is non-negative. So there is no bound on x2. Thus, the next equation is x4, which is 12 minus 2x2, which I want non-negative. And what does it imply? x2 has to be less than 6. And what is x5? That is 6 minus 2x2 larger than 0, and that means x2 is less than 3. So what is my leaving variable then? So I picked x2 to be the entering variable. What's the leaving? What's the leaving? x5. So x5 would be the leaving. Alright, so once I have that, now I have to do pivoting. And I have to come up with the next dictionary. Again, what should I do? I should go to the equation for which variable? Go to the equation for the leaving variable, solve for the entering, and then put the value of the entering in the other equations. Right? So if I do that, do you want me to show you the details of that, or is it okay if I write down just the dictionary? So my next dictionary will look like this. x1 is equal to 4 minus x3 plus 0 x5. Remember, x5 is going to take the place of x2. x4 would be 6 minus 3x3 plus x5, and x2 is 3 plus 3 half x3 minus half x5. And then I have the objective row, which is z equals to, maybe let me show at least for z what you should be doing. So how did I come up with the last equation? Remember, this was in my previous dictionary. I go to the equation for the leading variable. I need to solve for the entering, so I'm going to solve for x2. If I solve for x2, what do I get? If I solve for x2, I'm going to get, remember you have to divide by that 2, right? So you're going to get 3 plus 3 half x3 minus half x5, right? You understand that? From this equation, solve for x2. If you do that, you're going to get this equation. x1 is 4 minus, not x1, sorry, whatever the last equation is. x2 would be 3 plus 3 half x3 minus half x5. You agree with that? Once I have that, what should I do? I'm going to plug that in every equation, right? Wherever I see x2. Now, in the z equation, what did I have? In the z equation, I have this, right, in the previous dictionary. And what should I do? I should plug in the value of x2. What is x2? x2 is right here. Okay, so that's 3 plus 3 plus what? 3 half x3. 3 half x3 minus half x5, right? If you simplify that, aren't you going to get only what? x3 and x5. Am I right? So write that down. Simplify that. And if you simplify that, let's see what number you're getting. Do you see that I have a 12 there and a 15 there, right? So together, what do I have? 27. So I get a 27, and the rest of them I'm just going to write 9 half x3 minus 5 half x5. Good. So I have the new dictionary again. Unfortunately, we are not done yet, and this one I'm going to go over quickly. So to go to the next one, someone tell me from the back which one is the entering variable. From the last row, entering variable. What would be my entering variable? Someone from the back row. What is the entering variable now? x3, yes. Go to the 0, find the variables with positive coefficients and pick one of them. What is the leaving variable here? What is the leaving variable here? Let me show you the entire. So which column should I ignore now? Which column should I ignore now? The column for x5, because x5 will remain non-basic, which means it's going to remain 0. So my entering is x3. My entering is x3. So look at the column for x3 and the constant column. Now I'm going to say, well, x1 is equal to 4 minus x3, and that needs to be larger than 0, which tells you that x3 is less than 4. The second one is x4 is 6 minus 3x3, non-negative, implies that x3 is less than 2. The last one, do I need to write that? You see that in the last equation I can make x3 as big as I want. It doesn't make x2 negative. Right? When you have a positive coefficient for x3, notice that I can make x3 as big as I want. This will still be positive. So it doesn't put on any bound for x3. So all I have to do is look. So once you pick an entering variable, in the column for the entering variable, only look at the negative coefficients. Okay? You don't have to look at the positive coefficients, because they will let you take the entering variable to be as big as you want. So, enough. So which one is the smaller between 4 and 2? Well, 2. My leaving variable would be x4. Once I have x4, from x4, that equation, so look at the equation for the leaving x4, solve for the entering, and if you solve for the entering, what do you get? If you solve for the entering variable, you get what? Do you realize that I'm going to get 2 minus 1/3 x4 plus 1/3 x5. You agree with that? I didn't show you the details, but you can solve for that. And once I solve for that, then what should I do? I should plug that in where? In the rest of the equations. So plug in this value of x3 in the first one and the third one, and then simplify, and then you're going to come up with the following. I'm not going to show you the details here. So you get x1 is 2 plus 1/3 x4 minus 1/3 x5. x2 would be 2 minus 1/3 x4 plus 1/3 x5. And then what is sorry, this was x3, I think, right? This was x3. This was x3, and then x2 would be 6 minus half x4 plus 0 x5. And what is the value of z? 36 minus 3/2 x4 minus x5. Now, did I come to the final dictionary? Have I arrived at the final dictionary? Yes. As soon as all the coefficients of the 0 becomes negative, it will remain negative even if you try to do the dictionary. Which means that you have arrived at the final dictionary, and the value 36 is the optimal solution, optimal value of that objective function. Now what I want to do is sort of say, we didn't look at the feasible solutions so far. So in the second, so this was our first dictionary. We looked at this feasible solution was x1, x2, 0, and the other ones were 4, 12, and 18. What is the feasible solution in the from the second dictionary? Whoops. Can someone tell me what's the feasible solution here for this dictionary? X2 would be 0, right? X3 would be 0. What would be X2? Sorry, X1? 4. What would be X4? 12. And what would be X5? 6. But I want you to say, in terms of our original decision variables, what's the solution? What's the solution in terms of the decision variables? Not the selects. X1 is, what are the decision variables? X1 and X2. What is X1 here? 4, right? What is X2? 0. So that's our solution here. Remember, in terms of only the decision variables, in the first one, the solution is X1 is 0, X2 is 0, right? 0, 0. I'm just looking at the decision variables here. And the third dictionary, what's the solution? In the third dictionary, the solution is X1 would be 4, X2 would be 3, and then the other ones are X3 would be 0, X4 would be 6, and I'm missing 5, right? So X5 would be 0. So in terms of the decision variables, the solution is 4 and 3, right? 4 and 3. One more dictionary here. So here the solution is X1 is 2, X2 is 6, X3 is 0, X4 is 0, X5 is X3 is 2, right? And then X5 is 0. So in terms of the original decision variables, the solution is 2, 6. Everybody is right? Okay. Clear? And so what's the optimal solution? 2, 6. So what's the optimal value? 36. Let me show you what path geometrically did our Simplex took. Let me go back to the geometric view of this. Where is my... Okay, right here. Remember, this was the feasible region, right? So remember, our first initial dictionary gave us the solution what? Let me use magenta. 0, 0. Right? From there, what was our next solution? Our next solution was 4, 0. Right? And what was our next solution? 4, 3. And what was our next solution? 2, 6. So which way did we move? We moved in this direction, and then we moved in this direction, and then we moved in this direction. So the Simplex basically took you from 0, 0, 4, 0, 4, 3, 2, 6. Remember, at some point I had a choice between X1 and X2 to choose for an entering. What if I chose X2 instead of X1 then? I would be taking this path. I would have taken this path, but I have no way of knowing which path is smaller, unfortunately. Okay? There is no way for me to know which would be precise. We can see that one way would have been easier, faster, but there is no way of detecting that. Is that okay? Is everybody clear on this? Okay, go ahead and explore IOR, and it's going to let you do pivoting without you doing the calculations. So what you're going to do when you go to IOR, there is a F where you're going to choose your entering, you're going to choose your leaving, and it's going to do the work for you to do the pivoting. Am I making sense? So please explore that. I'm going to be assigning homework, and then you're going to have to use that to do that. Otherwise, you're going to end up doing it by hand, which is not going to be pretty. Okay? All right.